Okie dokie. So we've got this rectangle inscribed in a semicircle. This is my x-axis, this is my y-axis, and I want to find an equation for the area of this rectangle in terms of x. So I know that this distance here is x, and this distance here is y, which means that the base of my rectangle, since it's nice and centered in that circle, this is x and this is x, so the base is 2x and the height is y, making the area 2x times y. So base times height, 2x times y. But they want it all in terms of x, so I don't want any y's. I need to figure out a way to relate x and y, and that's why they tell me the radius is the square root of 6. Right, the square root of 6, yep. So since it's a rectangle, that's a right angle, and if I see that right triangle, I have the Pavlovian response, Pythagorean theorem, x squared plus y squared equals root 6 squared. So I can say that x squared plus y squared equals root 6 squared, so x squared plus y squared equals 6, and I can solve for y. So y squared would be 6 minus x squared, so y will equal plus or minus the square root of 6 minus x squared. But it's a rectangle, I can see that it's only on the top, so I'm going to ignore that plus or minus and just use the plus. Now I can substitute that in for the y here and get area as a function of x is just supposed to be 2x times root 6 minus x squared. And that's the answer they want for part A. For part B, they want to know when the area is 2 root 5. And so you want to know what value of x, what possible dimensions this rectangle could have to make the area 2 root 5. I just plug and chug, put that in, and I need to solve for x. So, to undo this square rooty mess, I'm going to square both sides. Square that side, square that side. So 2 squared is 4, root 5 squared is 5, so 4 times 5 is 20. 2 squared is 4 times x squared times the square root, and the square will cancel, so times 6 minus x squared. So, got to distribute that. 20 will equal 4, oopsie, I can multiply, 24x squared minus 4x to the 4th. Anytime I have an equation with a power higher than 1, my goal is to set it equal to 0 and attempt to factor it. So I'll send everything over to this side, 4x to the 4th minus 24x squared minus 20 equals 0. Everybody divides by a 4, so we'll go ahead and do that. X to the 4th minus 6x squared minus 5 equals 0. So the 0 got divided by 4 as well. Both sides totally legal. Now, I think I accidentally messed up that sign. That the 20 stayed on this side, so he should have been positive. Sorry about that. Making that 5 positive as well. Now I got to factor this guy. So I'll have an x squared and an x squared to make that x to the 4th. And to make the 5, I'll use a negative 5 and a negative 1 to make that negative 6 in the middle. So if this times this equals 0, then either x squared minus 5 equals 0, or x squared minus 1 must equal 0. So x squared could be a 5, or x squared could be a 1. So x could be plus or minus root 5, or x could be plus or minus 1. So 2 possibilities. So they want the entire dimensions. I found the length of x. So I just am going to talk about the base and the height. I basically have it. I'm just going to clean it up a bit. So I'm going to say if x is 1, then the base is 2 x's. So the base is 2. And the height is the y, so that's the square root of 6 minus 1 squared, so the square root of 5. So one possible dimension for my base and my height are 2 by root 5. And that would make a area of 2 root 5, right? Base times height, it's working. So now we do the same thing. If x was root 5, then the base is 2 x's, so 2 root 5, and the height is 1, which is the square root of 6 minus 2 root 5 squared. So that's, 2 times x, so 6 minus x squared, so 6 minus root 5 squared, so 6 minus 5 is 1, and that's another possibility for my base and my height, 2 root 5 times 1. It seems pretty obvious, picked some nice numbers, that one possible area could be 2 root 5 times 1, and that would work. So those are our possible dimensions, and that's that.